Hello and welcome to my live stream Fun with Interfaces episode 3 testing. I'm so very sorry. This is actually the second time I'm going live today. I have just completed delivering this session, and then at the end I realized something must be wrong here because there was absolutely no activity in the chat. And then I investigated a little bit. I realized something is badly wrong. So one deep, honest apology from the depth of my heart to all of you who have been here. Some of you have been waiting for an hour for something to actually start happening, and I really am sorry. So let's now try to make up for that. I'm now going to present Fun with Interfaces testability. Let me just first confirm that everything is fine. So please just tell me something in the chat window that you're here. I see that people are here. There were some comments, but it means that okay, cool. So I'm live apparently, and let's actually move on and let's start talking about interfaces. In the first two Fun with Interfaces episodes, I first presented what interfaces are in general. And then in the second one, I have shown how we can use interfaces in some patterns. And then I've teased what is going to happen this week when I'm going to talk about how to use interfaces in testability. The patterns I talked about were two. The first one is factory pattern. This is not that relevant. The second one is far more important. It is inversion of control group of patterns. And in this, in my particular example, it was dependency injection. So without much ado, let's actually move on into showing some code. First of all, you can all follow everything inside Git. So you can go to github.com. And then there is this vkob/fwi3. This is an actual, this is a repository which contains all of the demos that I'm going to present today. And when you compare that with the repository from the last week, which is fwi2, this one had 8 branches. Today has 4 branches, but demo 1 maps to demo 1, and demo 2 to demo 2, demo 4 to demo 4, and demo 8 to demo 8. So all of these 4 branches map to the exact same branch in the other one. So what is the difference then? Well, fwi2 is a functional app, currency converter app that you have seen last week, and fwi3 is a testability app. What I also have is let me just restart that. I have multi-root workspace. So what I have here is a workspace which contains 2 roots. The first root is fwi2, which is currency conversion app. And the second root is test tool, which is my unit test. As you can see, there's a lot of built apps in there. That's because I have just went on and duly presented everything an hour ago, only to figure out that this is not live and that nobody has actually seen it. Interesting, I saw that there were viewers in there, but when I was asking questions or typing in the chat, nobody responded. So I just thought, yeah, well, maybe audience is not that interactive today. But anyway, let's move on to demoing that. Let's first take a look at my first test code unit. And before I go there, let me just remind you of what it is that we are testing. So I'm testing my currency conversion functionality. So I'm testing that, and actually have to deploy that first, and I'm going to deploy that. So I'm going in here and I am deploying my app. And what does the app do? The app allows me to convert currency from, for example, euro to Croatian kuna. And then, yes, it fails because there is no setup. But this failure is actually expected. And this is a part of my demo today. So let's close this and then let's go back to code. So I'm actually writing some test to test this, some test code. And I first have this bad code unit. And this is a very bad example of a very badly written test code unit because, as is written in the comment, there are more code smells in there than there are lines of code. So When you take a look at a test written like this, you can know that this is a bad test because it violates a lot of test principles. First of all, it has very high sensitivity to data. So I depend on this euro and Croatian kuna to be configured in the database. If my database hasn't been pre-configured, this will fail. I also depend on a very specific exchange rate to be inside the database. And when I actually try to deploy this test application and then try to test this tool, I will see that it fails. So let me actually figure out how it fails and why. So I'm now inside my Business Central. Did it actually do anything? No, it didn't. I will have to reload. Business Central has issues when you have multi-root workspaces which have dependencies one on another, and then you change versions in the process. So there is nothing I can do about it. I will be reloading my window multiple times, and then I will be just opening and saving code randomly to make AL compiler extension aware of which app I'm actually trying to publish. So I'm now trying to publish app 101, and I'm going to try to run my test. So I'm going to AL test tool. I'm going to fetch my test code unit. I'm just taking this bad one for now, and then I'm going to run this test. And it fails because currency exchange is not allowed for Vieco. So as I said, there is some some setup missing. So let me actually put that setup in there. So I'm going to do currency permissions, and then I'm going to assign from euro to Croatian kuna allowed. So Vieco can now perform those conversions. And then when I take a look at my convert amount page, and I want to convert from 10 euro to Croatian kuna, I see that I get 54.65. So that's exactly the value that I've put here in my test code, and it should all work fine. So I'm going to rerun this test. This error should go away. And true, it did go away, but I get another one. It now fails because there is some rounding issue. So user interface rounds this 17 decimal place number to a 2 decimal place number. And this is what I didn't do in my test, and my test is failing even though it shouldn't. So this very bad code unit actually illustrates why it is bad and how you should actually think differently when structuring your test code. But test best practices are not a topic of today's session. Let's focus on this, I apologize, better written one. So, what I do in my unit tests is usually I make them have three stages. And this is something that is really a testability best practice. First, I set up my test, then I run the test, and then I validate the results. So this is what every test should have. So it has fewer anti-patterns, but it's still not ideal, and we will see why. First of all, I'm going to set up my currency conversion. So what do I do to set it up? I do two things. The first thing is I'm actually setting up the correct exchange rate, and here I'm specifying which exchange rate that should be, okay? And the second one is I'm setting up permissions. So I'm making sure that my permission is correctly present in the database when I need it. So I do not need to depend on some data to be present magically outside the test. Test has everything inside. And then when I take a look at that test, and when I get that second test code unit, and then run that second code unit, okay, this one fails because the record in the table already exists, and this is something I didn't see coming. Actually, I will do it like this. This is not something you should routinely do. It's actually an anti-pattern, but this is how things are often done in setup tables in Business Central. So I'm going to redeploy my test app. And then I'm going to go back to my test tool and rerun this selected test, and now it succeeds. So again, why it has succeeded? It has succeeded because I have first configured my test. I have defined which exchange rate I expect at what value. And then I have validated that the result is really as expected. So this was simple, and this is how tests were written all the way before interfaces came along. So you didn't have much other opportunity to create tests. You needed to set up your data to be there, then you needed to run your test process, and then you validated that everything was fine. But let's take a look at the second branch. Actually, I'm going to first fix this. And publish, and then I'm going to switch to branch number 2. So I will remind you what happened last week inside my branch number 2. So the first thing that branch number 2 does is that it realizes there may be different conversions. There may be Business Central setup conversion, which converts by Business Central setup, but also I may have a REST-based conversion, which calls a web service to convert. So what I want to have now in my code units is I want to test both. I want to test whether my setup conversion works if I'm using Business Central tables, and this is the first test. But also I want to test that that I can also invoke web service, and that the web service test works fine. So here I'm doing that as well. So I'm simply calling convert by setup and convert by REST, and I'm making sure that my setup works because this is my setup rate and this is my REST rate. So let me first deploy my version number 2. So I'm going to deploy the functional app first. It is now failing, and I will close my code, reload my window, then I will go back to my functional app, and then I will deploy my functional app version 02. That is fine. Now I want to deploy my test app. So I'm closing this. I'm going into my test app and then attempting to deploy that. Again, it does not work fine. I will try again. Yeah, now it works. So let's take a look at my test. So I'm first going to delete these lines, and I'm going to retrieve my my test is not there. Let me see what happened. Okay, so my currency conversion is not deployed. So let me see why my currency conversion is not deployed. Stopping this and then trying to deploy it again. I'm going to reload the window, reload the window again. And then now that I'm in the test app, I'm going to try to deploy that. And now my test app should be deployed. And it is. So my test tool is there. And then let's go to AL test tool, and then I'm going to get test code units, and then I'm going to retrieve the first one, and I'm interested in this conversion REST. So I run this selected test and it works fine. So why does it work fine? Well, because I know that today this is the currency. But you can see the problem there immediately. So while I can somehow, through my setup, ensure a specific currency exchange rate inside of my functionality that is being tested, how do I do that for my currency, for my REST web service? Let's take a look at what my better code unit does. Well, it handles correctly the situation where I need to have some data in Business Central. So this first function is fine. But let's take a look at currency conversion test, which is written using this better looking structure. So I try to set up my test. What I do is I specify which currency I want to use, and then I retrieve the currency exchange rate from my exchange rate service. So when I take a look at this, what I do here is I simply go to the same URL that I will use to convert, and then I'm going to retrieve the currency and then return the rate. And then I'm going to use that rate to I'm not going to use it yet. I'm invoking my convert by REST. This is invoking the same web service, which will now convert using the rate I used. And then I'm going to validate that the result I received is equal to this number, which is how much I wanted to convert, multiplied by this rate. And if this doesn't look like an exercise in futility, then I do not know what ever will. And this is why. When you take a look at my getExchangeRate function, well, everything all the way, like all of this, which is in essence the entirety of this getExchangeRate current exchange rate retrieval function, is nothing but the code which I already have here. So again, this is literally copy and paste. So this is not what you want to have, because if you validate one code by exactly the same code, of course the result will be correct. So we need something better. So you can immediately see that if you want to test external web services, we have some problems. And here, this is a perfect place to introduce a concept of test doubles. So what are test doubles? Test doubles are objects which substitute real production objects. They are used to simplify tests, they're used to make tests more reliable, and they're used to improve performance. And of course, these are not the only reason why we use them. The real reason why we use them is side effects. So what are side effects? This is something that we in AL world are not particularly concerned with. But if you talk to anybody who develops in, for example, F# or in any functional language for that matter, they would tell you that this is a very important thing. One of main imperatives of functional programming is to have pure functions. What are pure functions? Pure functions are those functions which receive input and return output without leaving any mess anywhere. And this mess that is left anywhere is side effects. Side effect is anything that happens inside of a function which doesn't pertain to the I apologize, I have unplugged my, I'll be right back. Yep, here I am. Let me just verify that my stream is still live. Yes, it is. So by the 15th time, I believe my stream will be quite fine. So back to side effects. Side effects is something that happens a lot in Business Central. In essence, we don't even care. Like you call a posting procedure, it will leave a lot of side effects because that's what the posting procedure should do. It should actually leave all of those, lines in the ledgers and registers and wherever necessary. So we just leave them out there. When we take a look at my exchange rate management code unit, well, it also has side effects. It leaves some results in a log. So this is a side effect. And all of these are not a good thing for testability. So let's take a look at what kind of test doubles we can have. We can have three kinds: stubs, fakes, and mocks. And what are these three? First, stubs. Stubs are objects which contain predefined data, which are used to answer some calls and to respond with some predefined results. So, for example, if you need to retrieve a data from a table or a web service, instead of you invoking actual web service or reading actual table, which can be slow, which can be unreliable, things can happen that it does not result in what you expected, you may want to actually replace it with something else. So you can replace them with stubs. The other kind of test doubles is called fakes. Fakes are actually objects which have working implementation. So they do perform whatever their actual production counterpart does. It's just faster, simpler than in production. It often takes shortcuts. An example could be, in my case here, with currency conversion. If you take a look at, for example, my structure here, is my check permission. When I'm checking permission, that could easily be a fake object. I may want to use a fake object to test permissions. So fakes will typically not do data access. They will typically have in-memory collections and representations simply to be faster and simply to substitute unnecessary operations. for the test process. And the last kind of test doubles that I'm going to talk about today is mocks. Mocks are objects which are used to register calls, make sure that some call has happened, and to validate a system state change that is otherwise difficult to validate. Also, mock test doubles are used to replace non-critical components of a process. For example, let's say that inside of your posting process, you want to send an email to a customer. So how do you validate that the email has been sent? Or do you really send all those emails as a part of your test function? Your test should not produce that kind of side effects. You don't care about them. They can even make things worse for you. So what you may want to do is you may want to use a mock for sending those emails. Because when an email was actually sent, it's very difficult for your test code unit to validate that kind of state change. Whereas if you use a mock, you can easily verify that specific component has been called and has performed its function. So, good. Now that I have presented all kinds of test doubles that we have, let's go back to our demo. And let me switch to demo 4. So I'm going to demo 4 in my testability, and I'm also going to demo 4 in my currency conversion app. And then I'm going to reload my window. I'm first going to try to deploy my currency conversion app. Let's see if it works. Nope, it's trying to do something else. Let me try to reload window again. And then deploy. This time it works. Okay, I'm going to close this. And now I'm going to close this as well. I'm going to load my test code unit. And I'm going to reload the window again, and then, I'm going to deploy my test app. And then if this succeeds, and it did, I'm just going to validate that I have the right versions of extensions. So my currency conversion is version 4, my currency conversion test is version 4. Nice. So let's take a look at what I have here. And again, at the same time, I'm going to delete this to make sure I start afresh. So the first thing that I have realized is that inside my process, where I'm testing my exchange rate management, my exchange rate management does not care about how you convert. It's concerned with this process, that it checks permission to make sure that you are allowed to convert. Then it converts using a converter, whatever this is, and you can check what it is last week if you check what I said about branch 4. And then my conversion process logs my result in the database. So this part, for example, can be either Business Central conversion, or it can be REST conversion. It can be something else. And that something else in my testability case is actually a stub. So let's take a look at my test code, at my doubles, and let's take a look at my converter stub code unit. So what I have here is a code unit which implements demo iConverter. So this is my interface which defines the behavior of every converter code unit. And my stub code unit simply is configured with a specific rate. And then when you call the convert function, it converts by simply taking the amount, ignoring the from and to currency code, and simply multiplying the amount by a rate that it was configured with. And then let's take a look at my test code unit. Inside my test function, what I do is I first set up my test. So this setup currency conversion now not only inserts a record in my setup table. This is again something I presented last week when presenting demo 4 branch. And again, let me just show this page. This setup page is simply here to specify which currency converter you want to use, BC, REST, or, well, it gives this stub. Normally you would not have testability application deployed, so this one would not appear. But this is what the setup is. So I'm configuring my setup to use the currency converter. This will be rolled back at the end. This is what I have taken care of with the transaction model for my function. So after I have set up my currency conversion process to use my stub code unit with this specific exchange rate, I'm simply making sure that this is the result, and then I'm asserting that. So this is now my test test function, and let's actually run that test function. So I'm going to get this test code unit, and I'm going to run my test, and this is going to work. So again, what I have done here is I have replaced an actual conversion code unit with a stub code unit. So as much as my users, when they call conversion process, they don't care which converter is used, they care that the configured one is actually used. My testability tests the same. It also makes sure that whatever is the currently configured converter, that one performs its conversion. And it will in fact validate that everything has happened correctly inside of this convert function. That's all nice. Another thing that I've done is I have added a enum extension stub. So I have added a value which implements this demo converter using this stub converter. So when I configure my converter to be stub converter, this code unit will be used. Unfortunately, this code unit has to be single instance. This is explained why. It's simply because we cannot control the process of instantiating specific instances to those code units that implement interfaces that are implemented on enums. This is simply not possible. So I have to use single instance, and this is something I dislike very much. And this is also, if you remember from my last week's session, this is something I slightly covered there, that I do not in fact prefer this way of retrieving setup from here, and that I want something else. And then we improved a little bit. So we had branch 5, 6, and 7, which improved a little bit on that design. And then we had the ultimate state of affairs, which was branch 8. And this is immediately where I want to jump into to show you what other kinds of test doubles we have. And we will actually see how we are using mocks and fakes as well. So what I'm going to do first is I'm going to switch my branches. I'm going to switch to branch 8, and then I'm going to switch to branch 8 in here as well. Then I'm going to reload my window. Then I'm going to deploy my app first, and then let me reload my window again for that. I'm now running my app. Again, it didn't deploy the correct version. Let me run it again. Yeah. And then let me deploy my currency exchange test app. So I'm going in here, and I'm now going to reload my window again. And then I'm going to try to deploy this app. And it seems to have succeeded. Let's validate. Let's check. Let's actually delete these lines first. And then let's check if I have the correct versions of extensions. So version 8 of both. So as much for the test. Pardon the delay. So let's focus on what we have here. Let me go into my exchange rate management code unit. One thing that I presented over branches 5, 6, and 7 is how we can introduce more functionality and more features into this, and one of them was actually a pattern called dependency injection. So what dependency injection is, it's a pattern where you are injecting the dependency into a function if that function needs such a dependency. My currency conversion function has 3 dependencies. It has permission checker dependency, it has converter dependency, and it has logger dependency. And if we take a look at this process, currency conversion, it has 3 essential parts. First, it has to check if the user is allowed to perform it. Second, it needs to perform it. And third, it needs to log the fact that it has been performed. But what this process doesn't care about, it doesn't care how permissions are checked. It doesn't care how conversion process was completed, how was this amount A converted to amount B. And it doesn't care how and where it has been logged. For all it cares, this can be some web service, this can be based on data in Business Central, and this can again be, I don't know, Windows event log or whatever. Or it can all be Business Central, or it can all be REST, but this process does not care about those dependencies. So what I have is that I have injected these dependencies, I have injected the converter, I have injected the permission checker, and I have injected the logger into this exchange rate management code unit. And then I have my page from where I have first used my dependency factory. Again, if you do not remember what it is, check my last week's session. And there I have created an instance of my converter, permission checker, and logger dependency using my factory. And then I have passed them, or I have injected them into my conversion code unit. So this means that my testability can now inject its own dependencies. It doesn't have to use the runtime or production dependencies. And this is what I have done. First, that one that we have seen is this stub converter. So this stub converter is receiving an exchange rate, and then it's using that rate to multiply the amount. But I have more. One other dependency that I'm using is this code unit mock logger. So I'm using a mock logger. Again, if you remember what I said about mocks, mocks are such test double objects which are used to make sure that something has happened and to figure out if the system state has changed in all those situations where it can otherwise be difficult to check if the state has changed. So, okay, it's not that difficult to figure out if a log entry is actually there in the database, but still we do not want to unnecessarily write to the database using during our tests. So what I have is a mock logger where I simply log the fact that it was used. So this called will be false if this never happens. And then I can check if it has been called. And this is what I'm doing here. I'm simply passing this mock logger into my converter. I'm injecting the mock logger, and then I'm asserting that logger has been called. And if it wasn't called, then this will fail. And this is the only thing I care, really, from the perspective of this process. I only care that it properly calls whichever logger I have told it to call. So the last one is this stub permission checker allow. And if I take a look at that one, this again simply replaces my permission checker with always allow. So no matter what conversion I try to run, it will simply always allow that. And this is the first function that I use, is I try to exchange using my stub converter, my stub permission checker, and my mock logger. And then I simply perform the validation. I check that the result is what I expected it to be, and that the logger was really called. So let's take a look. If I retrieve this code unit, this is the first test-based process flow. I'm going to run that, and it succeeds. Well, this was no surprise. Let's take a look at what else I can do. Since my exchange rate process has a very essential part, which is security, I want to make sure that security actually works properly. So I have two stubs. I have a stub which always allows, no matter what, and stub which always denies, which is going to be used for when I want to check if there is a deny permission in the database. So what I also have is two tests. I have security allow and security deny, and they are exactly the same. The first one is simply using this stub permission checker allow. The second one is using stub permission checker deny. And then I also have a mock converter, as you can see. What is mock converter? Well, again, I'm using it to check if a converter was called. I don't care about actual conversion or whatever it returns. That's not my concern for this test. What I'm concerned is that if conversion is denied, neither logging nor conversion should be called, and if conversion is allowed, both conversion and logging should be called. And then let's try to run these two tests. So I'm going to select allow and deny. So I'm selecting allow and deny, and then I'm running these two tests, and again they both succeed. So with this I have made sure that my security is actually observed, so that my process is actually making sure that essential parts of the process are not performed when the user has no permission to do that, and that they are performed when the user has permission to do that. And then last one that I want to test is whether I can really run this conversion in specific security scenarios. So what I want to test is that my converter performs the actual security check. But again, I'm not using the actual permission checker. I'm going to use a fake permission checker. So before I go into this fake permission checker, let's take a look at what I want to test. I want to test a scenario where a user is allowed to run conversion from euro to Croatian kuna, is allowed to run conversions from US dollars to anything, is allowed explicitly to run GBP to Croatian kuna, but is denied GBP to everything else. And with this, I'm really testing all of scenarios. I'm making sure that I can declare an explicit permission for currency from, currency to, that I can cover all of currency to for a specific currency from, and I can check that deny is stronger than allow. So what is this security? It's fake permission checker. So it's a fake test double. So this one has public functions allow and deny, by which I store some permissions inside my in-memory representation of my security. So what I'm doing here is I'm setting it up. I'm simply calling these functions. And then I run test with security. This run test with security receives my from currency code, my to currency code, whether or not it should pass the security test, and then the interface on which I'm going to run the actual security check. So what do I do inside? Well, inside my assert error block, I run my exchange rate manager. Here I'm using both mock converter and mock logger. I, again, do not care about specific conversion, and I do not care about logging. I actually just want to see that if I pass security, then this should be true. And if I should not pass security, then these should be false. Also, what I want to make sure is that if there is security problem, this should throw an error, and assert error will capture that. But if this actually does not throw an error here, it means if I expect it to pass security, then I throw an error to make sure that assert error is satisfied. Good. And then I can see that I'm actually testing that I can convert. So from euro to kuna, true, which means this should succeed. From US dollar to Croatian kuna, this should succeed too, but these both should fail, and also any implicit conversion where I didn't even set up this combination at all should also fail. So if I take a look at my security setup, I can run these tests, and this succeeds. Again, I have tested my security business logic. I have made sure that my tests work without ever having to depend on any setup being there or writing any actual setup in the database and then going through some even perceived pain of actually cleaning it up or not, but it doesn't matter. This is far simpler to test this way than with actual data having to be there. And there is one last thing that I want to test. I want to test my page. So if you remember, there is this page, which when I invoke, it performs all this business logic. It retrieves the setup and then applies that setup using a factory. So it actually reads this setup, and then it uses these configuration values to feed the factory. So this is my dependency factory. How does dependency factory work? Dependency factory again works in a way that I have converter, permission checker, and logger factory functions. All of them first call a discovery event, and if anybody responds to that event, that somebody should handle it. So handled should be marked as true, and I exit. And if nobody responds to this event, then I simply read my setup, my actual data in my actual production database, and then I use whatever converter is there. I use that from my page when I construct or retrieve an instance of converter, permission checker, and logger. I inject these three into my exchange rate management process. So I want to test this page. I want to make sure that this page works, but again, I want to use test doubles for this. So how do I do that? Well, I have that as well. First of all, I have interface discovery code unit, which has manual subscribers. These manual subscribers are discovery for converter, discovery for permission checker, and discovery for logger. And inside all of them, I actually assign default converter, default permission checker, and default logger, and I set handled to true in all of them. And then I initialize this one by passing or injecting the actual dependencies I want to use for this specific instance. Then my exchange rate management the test code unit, which tests page discovery. It uses this interface discovery, and it initializes my page with stub converter, stub permission checker allow. Again, I do not want to complicate this process. I'm simply checking allow, and mock logger. And then I bind subscriptions. I make sure that this interface discovery code unit will respond to those discovery events. And then I mimic the user, opening the page, setting the value into from amount, setting the value into the from currency code, and setting the value into to currency code. So I'm using this setup that I have used with my stub converter code unit. Then I'm evaluating I'm reading the value from the to amount field, which should have been validated simply through the validation that happened here. And then I'm making sure that my result of my conversion is correct, and I'm also making sure that my logger has been called. Of course, if it fails on security, there should be an error at some point over here when this validation happens. So let's take a look at what happens when I run my last test, which is page discovery test. Again, it succeeds. So if this doesn't look beautiful to you, then I've totally failed in presenting interfaces. But this is actually amazing, because not only testing the system by structuring the code this way is easier, it's also your code looks better. You are really applying the best practices of coding practically everywhere. You have single concern objects which are involved when they need to be involved. You can substitute all of the objects with their test doubles, which can be fakes, mocks, or stubs. There are other ones which I didn't cover in this session. They are not that relevant. They're called spies and dummies, but it doesn't matter. The beauty of this is that you can really destructure a process. You can eliminate the need to set up the data, to make sure that the data is there, that setups is there. So actually, when you just structure it this way, both your tests are more robust, more focused, more performant. So is your actual runtime functionality. So this has been all I wanted to present from the theory perspective, and then let me now focus on questions. So let's take a look if we have any questions. Gerardo Daniel Renteria Garcia says, hola, todo bien? Muchas gracias. I'm glad to know that everything is fine. Imran Khan says, better quality today. Thank you. I'm glad, except for this one glitch where I managed to pull the reflector cable with my foot. And now let me address any actual questions. So do you have any suggestions? Questions? Anything, please. I was actually sitting in this window like for 5 minutes in my first stream, which just got gobbled up by YouTube, and I was looking at my face in the live window, and I was sure people were here, but I didn't know why nobody's saying anything at all. And yeah, also now nobody's saying anything at all, so I would just believe that having you wait for an hour was already too much and you didn't want to stay. You simply maybe the number of viewers number is incorrect, maybe it's not live, maybe nobody is here at all at this point. I will wait for a couple of more seconds, and then I will move into closing the session. I'm not done for today. There are more things that I want to say. So I'm going to move into closing this session. If there are any questions, I'm going to address them at that point. So today I want to make two announcements. The first announcement is that today at 4:30 p.m. Central European Time, there is 18th BC Beerinar. Topic of this Beerinar is just open discussion, just the Christmas party of the Business Central community. So please join. I will be there too. Join your peers in the community and let's discuss whatever topics come to our minds today. And then the next announcement I want to make is that next month, which is January 2021, January 11 to 13, I'm going to deliver a webinar on Git. It's called Leveraging Git, and the idea of this webinar is that I present Git not just as a tool which we use to commit and create branches and push, but as an essential development tool which boosts our productivity. So it will have 3 sessions. In the first session, I'm going to explain Git internals, how Git internally stores information. I believe this is very important because when you understand how tool works, only then you can be a true master of that tool. The second session will be common Git operations, where I will present a lot of Git operations, maybe some of those which are not used on daily basis, but by a lot of developers, with an intent of actually making you familiar with those. And then the third session will be advanced Git, where I will present some advanced Git concepts and topics, such as, for example, undoing commits both before and after pushing and similar. So check on my blog how to sign up for the webinar. It is not free, I have to say, but still for all of the viewers of my Fun with Interfaces session, I give a special discount of 15%. So you can just mention there, I watched your Fun with Interfaces 3 or something similar. I will know, and then I will assign discount of 15% to you. So that would be all. Thank you very much for following my session today, and let me see if we have any questions. So no questions, just a nice thank you from you all. So one thank you from me to you as well. Have a nice weekend, have a nice BC Beerinar, and see you next time. I will announce on my blog when that will be. It will probably be on 8th of January, and I will also announce what topic that is. For now, it's going to be Christmas holidays, so have nice holidays, relax a little bit, spend some time with your family, and see you soon in the cloud. Bye.